Good morning, everybody. It's Miss Baines here. Hope you're all doing well. Sorry I can't be there in class with you. Unfortunately, even though I'm feeling better, it's protocol that I stay out until Wednesday. I went through your research stations to see if you guys got started on those and noticed that nobody took the plunge. So I'm going to go over a couple of things in order to help you get started, and hopefully that will make it less glooming. Okay, since I don't have my notes in front of me, I just pulled up the basic ethics of psychological research, just so that we're all on the same page. Some common ethical guidelines. The rights and well-being of participants must be weighed against the study's value to science, right? It has to be good for humankind. Participants must be allowed to make an informed decision about participation, right? Informed consent. Deception. Any part of the study that you have to deceive the person must be justified. You must do this only if absolutely necessary. Number 4, participants may withdraw from the study at any time without any questions asked, no pressure from the researcher. Number 5, participants must be protected from risks or told explicitly of any potential risks. Right? That's your basic do no harm, both psychologically or physical. Investigator must debrief participants, telling true nature of the study and expectations of the results. So after the whole thing is over, if there was any deception or what the real purpose of the study is, that investigator, the researcher, must debrief the participants. And finally, the names and data must remain confidential from anybody who participated. Okay, so let's just go from there. Okay, so you're going to be needing your notes, your binder notes for all of this stuff. So make sure that you have them out next to you, presented in each of these scenarios. Okay, so the first one, the fear of snakes study. A researcher who is studying procedures for reducing fear of snakes had her graduate student telephone her undergraduate students to determine their willingness to participate in some experiments. The investigator was unaware, however, that the graduate student told the undergraduates that they had to participate. If you want this teacher to give you an A, you better participate type of scenario. Does this represent an ethical problem? Who, though, is responsible in this case? So down here is where you would go back to your notes, and of course you have to get informed consent, but you can't bully people into giving informed consent. Who's responsible? You'll probably be surprised to hear not the graduate student, right? It's the professor, the investigator, the researcher who has to make sure that every part of her research is checked and balanced. Okay, so yes, it's a problem due to requiring participation. All participation in all research must be voluntary and by informed consent obtained by the researcher from each participant. So the investigator or the professor, not the graduate student, is the one that's going to be in trouble here. It's her job to make sure that the research is ethical. Okay, I'm going to do one more of these with you. Number 2, the cartoon response study. An investigator was interested in how children would respond physiologically of the body while watching different kinds of cartoons. The dependent measure was galvanic skin response. So the wires would test how much nervousness the kid was experiencing through any kind of perspiration being registered on the wire. However, during one session, a young subject became so upset they had to stop the session and send the child home, crying with his parents. The investigator was unaware why the child was so upset. Later, the parents called to tell them that the child thought blood was being extracted from him because the electrodes had red wires and red ink was used in the recording pens of the polygraph machine. So Here, obviously, it's for sure unethical, right? Mostly because the child left differently than he or she arrived. Also, because when a minor participant is involved, they could not sign a legal document for themselves, like informed consent. Therefore, assent must be obtained continuously throughout the research. Remember that? Assent is checking in with the child. This means the researcher must fully explain what is happening within the study in a way that the child understands, and then repeatedly ask that child throughout the session if the child is continuing to understand everything that's going on, and to continue to ask, are you okay? Is everything all right? Do you want to stop? Do you want to take a break? Do you want a juice box? That type of thing. Okay? So there you have it. Those are two examples of the way that you need to approach the. Everything is right there in your notes. Okay, so the next station is about operational definition practice. Remember, there are things in psychology that we are measuring that you can't measure with a scale or a ruler or a stopwatch. Things of the heart or the mind, right? Things like happiness or things like alertness. You can't just measure that with a ruler. So you have to operationally define what it is you're measuring in whatever you're doing your research on. So let's read the directions here. Read each scenario below. First, determine what a researcher is measuring in each scenario by highlighting or circling the term. See the first example below for help. Then, write an operational definition for that variable so that it is now measurable. In other words, describe how the researcher will measure that variable. Okay, so the example says here, an entrepreneur looking to purchase a local gym wants to know how much exercise impacts happiness, right? So happiness is what he wants to measure. So he has to come up with a way to measure each person that works out how much happiness they felt immediately following the workout. So the operational definition, therefore, will be researchers will give gym members a little survey of happiness, rating of 1 to 5 before they exercise, and then again after they exercise. So how happy are you feeling right now before you get on that treadmill? Scale of 1 to 5. 2. Okay, you go on there for an hour, get off of the treadmill. How happy are you feeling now that all those endorphins are going? 5+, yay. Okay, clear enough. But I know that this is the first time you guys are doing this, so I'm going to do another one with you. An industrial organizational psychologist is researching how the quality of staff and employee-only areas, such as a staff lounge or a lunchroom, impacts their work productivity. Okay, so what we're measuring here is work productivity, and it asks in the directions for you to highlight what it is that you need to come up with an operational definition, or what you need to define operationally. So work productivity. Let's just say we're in a factory and we're putting zippers into denim jeans or denim jackets. Okay, how many zippers can your employee put in if they have a 15-minute break every couple of hours compared to no break at all? So the operational definition here, obviously, the researcher would have to give a test of productivity before the study to see what the level is at, and then conduct the same test after the study. This test could be simply how quickly it takes the worker to put one zipper in, right? So you measure for 15 minutes before the break, and then give the 15-minute break, and then ask them to do as many zippers as they can afterwards. Or the test could simply be how quickly the employees type before and after, or how many items they produce in one day. For instance, if the work is, like I said, in a zipper factory or another factory of some sort. Okay, there you have it. Okay, the next section is correlational practice. Okay, so as we know, in a correlational study, you're looking at a relationship between two variables. So you also should have learned from the video there's a slope. When you're imagining these two variables on a graph, there could be one that goes up and one that goes down, and that's what makes it a negative correlation, right? A negative slope. Both of them are going either up or down. It's a positive slope. Okay, so it's the easiest way to learn these are to do a bunch of them. So let's do these first two together. For the following correlation findings, state one, or first, whether the correlation is positive or negative, and then two, what possible third variable or confounding variable might explain these particular results. Some examples are imaginary. Okay, so the first one, right? And I encourage you, as you're doing these on paper, to put a little arrow over what goes up or what goes down. And in this case, since you're doing it on a computer, to use your thumbs. Right? One up, one down is always negative. One down, one up is always negative. Two up or two down are always positive. Okay, so the more rooms a person has in their house, right, the more rooms is positive, right, going up, one thumb up. The more pairs of shoes they are likely to own, thumbs up, more and more. So two things going in the same direction is a positive slope. A possible third variable might be not that the person has more rooms in their house, that they have more shoes. Maybe they just make a lot of money and they're able to buy more shoes, right? So that correlation isn't necessarily causation. And in fact, in correlational studies, you never want to say one thing is causing the other. In this case, it's probably due to the fact that they make a lot of money. Or maybe they have a lot of kids with lots of shoes, right? Could be something totally different. Okay. The second one, the more class days that students miss, okay, thumb up, the lower their grades are likely to be, thumb down. That means that we have a negative slope, one up, one down. Perhaps the possible third variable could be there's an illness in the family or the kid is sick. Maybe there's a divorce going on. Maybe they're poor. Maybe they're homeless. Maybe there's a new baby and the older kid has to watch the younger kid. Who knows? All I know is it doesn't mean that the situation is positive or negative. It means that when you put them on a graph, that it's going to slope down because one is up and one is down. Okay? As simple as that. You want to do one more? The more expensive a person's car is, right? Thumb up. The fewer successful, intimate relationships they have. Thumbs down. Okay? Maybe, though, we know it's a negative slope, right? We have another negative slope because one is up, positive, expensive, and the fewer is down. So one up, one down is a negative slope, and maybe the guy just has a bad personality, and that's why he doesn't get dates. Right? Maybe he's a jerk. A misogynist, a woman hater. Who knows? All right, hopefully that helped you out. Okay, next up, you simply have to identify the type of research method. So open up those notes, crack them open. Is it a case study? Is it correlational? Do you use a survey or questionnaire? What is it? How are you running your study based on what you're studying? Okay, number one, participants were asked to answer a number of questions about their study habits. The answers to those questions and participants' GPAs, grade point averages, were examined for patterns. The researchers found a strong relationship between the number of hours spent on social media and a lower GPA. Okay, so what do we have there? A correlational study, right? You're collecting data by comparing two variables. How much time a teenager spends online with their social media and what their grade point average is, to see if there's some relationship so they can write an article about it. Okay, that's it. Next one, we'll do one more together. Researchers wanted to see if the COVID-19 virus led to low birth weight. The birth weight of babies born to mothers who tested positive for COVID shortly before or during labor was compared to the birth weight of babies who were born to mothers who never contracted the COVID virus. Okay, so this one, of course, would be a quasi-experiment. Why? Because it's not randomized. You can't make your participants contract a virus just for the sake of collecting data. You can use people who already have the virus and take note of it, but they're not random. Absolutes in good research is that you want randomized people participating. Okay? So go ahead and hopefully you go back to your notes and you took good notes on all those different things like case studies, observational, naturalistic setting, all those things that you learned in my video on research methods. Okay, and the very last station, station 5, you're going to fill out a Google form by going to the National Center for Case Studies. Okay, so you're going to go to this form. Go to the National Center for Case Study Teaching and Science website at H blah blah blah. You're going to search the collection and type in the keyword brain into the bar that says your search should load case studies about the brain. You can skim the studies and select one study to read. Select the study and click the green button that says download case. You will read about the study, but you do not need to answer the questions already included in the document. Okay, so here you're just going to put your name, and after reading the case study, write a summary about the unusual case and what can be learned from that study. Explain the limitations of the case study. Your response should be about 5 sentences long. And that's it. So let me show you how to do that. We're going to go to the case studies. You're going to search case studies for brain. You're going to get all these cool case studies. I Was the Clumsy One, The Anatomy of an Assassination, The Frozen Addicts, Monkey Brains. It goes on and on. Let's see. Little Girl Lost, Yvette's Brave Battle, Rough Games in the Brain. So you just click one, download it, read it, and write about it. That's it. Hope that helped. Bye, everyone. See you Wednesday.